Hello, everyone, and welcome back to Tech Cloud Solution. If you're preparing for the Microsoft AZ-104 Azure Administrator exam, you have likely encountered the massive scope of the curriculum. Many candidates spend weeks memorizing service definitions only to find the actual exam scenarios feel entirely different. Over the past few weeks, a wave of learners from this community passed their exams on the first attempt with scores exceeding 800. Their feedback suggests a common shift. They moved away from memorizing lists and toward analyzing the logic behind Azure's architecture. In this session, we are analyzing the mechanics of every question. We will focus on the specific reasons why an option is correct and identify the exact flaws in the distractors. Microsoft builds these questions to test your ability to navigate dynamic environments. Understanding the why is the only reliable defense on exam day. Grab a notebook and let's apply this framework. Question 1. You are implementing Azure Private Link for your Azure storage accounts. How does Private Link enhance the security of your storage access compared to accessing it over the public internet? Options. A. Provides a private endpoint. B. Increases bandwidth. C. Uses public IP addresses. D. Enforces TLS encryption. This question asks how Azure Private Link improves security for storage access. Focus on the network isolation aspect, how data traffic is routed. Correct answer, A. Provides a private endpoint. Azure Private Link creates a private endpoint in your virtual network. This means traffic to your storage account travels over Microsoft's private backbone network instead of the public internet, eliminating exposure to public IP addresses and reducing the attack surface. Why the other options are wrong. Option B, increasing bandwidth is a performance concern, not a security feature. Private Link does not specifically increase bandwidth. Option C, Private Link actually avoids public IP addresses. Your storage account is accessed via private IP within your VNet, not a public address. Option D, TLS encryption is enforced by Azure Storage regardless of whether Private Link is used. It is not the defining security enhancement of Private Link. Exam tip: Private Link equals private endpoint in your VNet, no public internet exposure. Question 2. You are troubleshooting a performance issue with a web application running on Azure App Service. You want to see the detailed request and response logs for the application to identify the root cause. Which app service feature can you enable to capture these logs? Options. A. App Service Authentication Logs. B. App Service Deployment Logs. C. App Service Web Server Logs. D. App Service Diagnostics Logs. This question asks which app service logging feature captures HTTP request and response details. Think about what web server logs typically record in any hosting environment. Correct answer, C. App Service Web Server Logs. Web server logs capture detailed HTTP request and response information, including status codes, request paths, and response times. This is the feature specifically designed to help troubleshoot performance issues and identify problems with incoming and outgoing traffic. Why the other options are wrong. Option A. Authentication logs only capture information related to user sign-ins and identity validation. They do not provide detailed request-response traffic data needed for performance troubleshooting. Option B. Deployment logs track application deployment events such as code pushes and configuration changes. They are useful for debugging deployment issues but not for analyzing runtime request-response performance. Option D. Diagnostics logs provide general application insights like crash dumps or trace logs. While helpful for debugging application-level issues, they do not capture detailed HTTP request-response traffic like web server logs do. Exam tip: web server logs equals HTTP request-response details, best for performance troubleshooting. Question 3. You want to monitor and audit access to your Azure storage accounts. Which Azure services or features can you use to track storage access logs, generate reports, and detect suspicious activity? Options. A. Azure Activity Logs. B. Microsoft Defender for Cloud. C. Azure Monitor. D. Azure Storage Analytics. This question asks which Azure service centralizes storage access monitoring, reporting, and anomaly detection. Think about which service integrates with log analytics for advanced querying. Correct answer, C. Azure Monitor. Azure Monitor collects and analyzes telemetry data from Azure resources, including storage accounts. It integrates with log analytics to query access logs, detect anomalies, and generate reports. This is the recommended service for centralized monitoring and auditing of storage access. Why the other options are wrong. Option A, activity logs only capture control plane operations such as creating or deleting a storage account. They do not record data plane operations such as reading, writing, or deleting blobs and files, so they cannot fully audit storage access. Option B, Microsoft Defender for Cloud, formerly Azure Security Center, provides security recommendations and threat detection, but does not directly track or log detailed storage access events. It is more focused on compliance and security posture management. Option D, Azure Storage Analytics was a legacy feature for logging and metrics. It has been deprecated in favor of Azure Monitor and diagnostic settings. Using storage analytics is no longer recommended for new deployments. Exam tip: Azure Monitor plus Log Analytics equals centralized monitoring, auditing, and anomaly detection for storage. Question 4. Your organization is using Azure Key Vault to store sensitive configuration values, such as secrets and connection strings. How can you securely reference and utilize these secrets within your ARM templates or bicep files during deployment? Options. A. Set access policies in Key Vault to allow the deployment to retrieve secrets. B. Define parameters in the template to accept Key Vault secret URIs. C. Use the reference function in ARM templates to retrieve secrets from Key Vault. D. Use the list function to get Key Vault secrets in ARM templates. This question asks how to securely integrate Azure Key Vault secrets into ARM bicep deployments. There are multiple correct approaches. Think about permissions, parameters, and ARM functions. Correct answer: A, B, and C. Option A, access policies, or RBAC. Ensure that only authorized identities, such as the deployment service principal, can retrieve secrets securely. Option B, ARM bicep templates can reference Key Vault secrets by passing the secret URI as a parameter, allowing the template to dynamically pull the secret during deployment without exposing sensitive values. Option C, the reference function is specifically designed to securely fetch values from Key Vault during deployment and is the standard integration method. Why the other options are wrong. Option D, the list function is used to retrieve collections of values like keys or certificates, not secrets. For secrets, the correct approach is to use the reference function. Exam tip: Key Vault ARM access policy plus secret URI parameter plus reference function. Question 5. Your organization is expanding its use of Azure storage accounts. How can you utilize Azure Resource Manager templates to automate the deployment and configuration of storage accounts with consistent settings and best practices? Options. A. Define templates with JSON. B. Configure using Azure Portal. C. Use Azure CLI scripts. D. Implement with ARM APIs. This question asks about using ARM templates specifically for automating deployments. Understand the difference between ARM templates, CLI scripts, and APIs. Correct answer: A. Define templates with JSON. Azure Resource Manager ARM templates are written in JSON and allow you to declaratively define resources such as storage accounts. By using templates, you can automate deployments, enforce consistent configurations, and apply best practices across multiple environments. This ensures repeatability and reduces manual errors. Why the other options are wrong. Option B. While the Azure portal allows manual configuration of storage accounts, it does not provide automation or consistency across multiple deployments. This option is not aligned with the requirement to use ARM templates. Option C. Azure CLI can automate deployments, but it is imperative rather than declarative. ARM templates are the recommended approach for consistent, repeatable deployments at scale. CLI scripts do not provide the same level of structure and governance. Option D. ARM APIs allow programmatic interaction with Azure resources, but they are not the standard method for defining reusable templates. The question specifically asks about ARM templates, which are JSON-based, not direct API calls. Exam tip: ARM templates equals JSON plus declarative equals consistent, repeatable deployments. If you'd like the complete PDF, full mock tests, and additional practice questions, visit our website. Everything is organized in one place to help you prepare more effectively. The link is in the description below. Check it out and continue your preparation. Question 6. You are deploying a Node.js application to Azure App Service. Which deployment method would you choose if you want to directly deploy your application code from your local development environment? Options. A. FTP. B. Local Git. C. Azure DevOps. D. Azure CLI. This question asks which deployment method enables you to push code directly from your local machine to Azure App Service without external pipelines. Correct answer B, local Git. Local Git deployment allows you to push your application code directly from your local development environment to Azure App Service. This method sets up a Git repository in your app service, and you can deploy by pushing code changes from your local Git repo. It is the most suitable option when you want direct deployment from your local environment without relying on external CI/CD pipelines. Why the other options are wrong. Option A, FTP can be used to upload files to app service, but it is not the recommended method for deploying application code. It lacks version control, automation, and integration with development workflows. Option C, Azure DevOps is a CI/CD platform that integrates with app service for automated deployments. While powerful, it is not a direct local deployment method. It requires pipelines and remote configuration rather than pushing code directly from your local environment. Option D, Azure CLI can be used to manage resources and trigger deployments, but it is not the primary method for directly deploying application code from a local environment. It is more suited for scripting and automation tasks. Exam tip, local Git equals push code from your laptop directly to app service. No pipelines needed. Question 7. You need to monitor and audit access to Azure resources for compliance and security purposes. Which Azure services can you use to track and analyze access logs? Options: A, Azure Cost Management, B, Microsoft Defender for Cloud, C, Azure Monitor, D, Azure Backup. This question asks which service is primarily used for monitoring and auditing access logs in Azure. Focus on what each service is purpose-built for. Correct answer, C, Azure Monitor. Azure Monitor collects and analyzes telemetry data from Azure resources, including activity logs and diagnostic logs. It enables tracking of access, auditing, and compliance reporting. With Log Analytics, you can query and visualize access patterns, detect anomalies, and generate compliance reports. This is the primary service for monitoring and auditing access in Azure. Why the other options are wrong. Option A, Cost Management focuses on tracking and optimizing spending in Azure. It does not provide access logs or auditing capabilities for compliance. Option B, Microsoft Defender for Cloud, formerly Azure Security Center, provides security posture management and threat protection, but it does not directly track or analyze access logs. It complements monitoring, but is not the main service for auditing access. Option D, Azure Backup is designed for data protection and recovery. It does not provide monitoring or auditing of access logs. Exam tip Azure Monitor equals access logs plus audit plus compliance. Use Log Analytics for queries. Question 8. Your organization is using Azure Monitor to monitor the performance of its Azure SQL databases. Which performance metrics are relevant for monitoring Azure SQL databases, and how can you use Azure Monitor to track these metrics and identify potential performance issues? Options: A, memory usage, B, blocked by firewall, C, number of failed logins, D, deadlocks, E, CPU utilization, F, disk queue length. This question asks you to identify which metrics relate to SQL database performance versus security/connectivity. Separate performance indicators from access control indicators. Correct answer A, D, E, and F. Memory usage A is critical as insufficient memory leads to slow query performance and increased disk I/O. Deadlocks D occur when transactions block each other and indicate query design issues. CPU utilization E indicates resource contention or inefficient queries. Disk queue length F measures I/O requests waiting to be processed, indicating storage bottlenecks. Azure Monitor can track all these metrics and trigger alerts when thresholds are exceeded. Why the other options are wrong. Option B, firewall blocks are a connectivity and security issue, not a performance metric. While important for access control, it does not measure database performance. Option C, failed logins are a security and audit metric, not directly related to performance monitoring. They are useful for detecting unauthorized access attempts, but not for performance tuning. Exam tip SQL performance metrics equals memory, CPU, deadlocks, disk queue, not firewall or logins. Question 9. You are backing up an Azure VM that has multiple disks attached. You want to ensure that all disks are included in the backup. Which Azure Backup configuration option allows you to include all disks in a single backup job? Options: A, differential backup, B, disk exclusion, C, incremental backup, D, full backup. This question focuses on which backup type captures all data across all disks in one job. Think about what full means in the context of backups. Correct answer, D, full backup. When backing up an Azure VM with multiple disks, a full backup ensures that all data across all disks is captured in one backup job. This simplifies the backup process and ensures data consistency during restores. Why the other options are wrong. Option A, differential backup captures only the changes since the last full backup. It does not guarantee all disks are included in one complete snapshot. It depends on the previous full backup. Option B, disk exclusion is the opposite of what is needed. It allows you to exclude specific disks from backup, reducing coverage rather than ensuring all disks are included. Option C, incremental backup only captures changes since the last backup of any type. While efficient for storage, it does not represent a complete point-in-time capture of all disks. Exam tip, full backup equals all disks, all data in one job, best for complete VM restore. Question 10. You are deploying a containerized application that requires a specific version of a programming language runtime. How can you specify the desired runtime version for your container in the deployment configuration? Options. A. Use environment variables to set the runtime version. B. Set the runtime version in the deployment YAML file. C. Specify the runtime version in the Dockerfile. D. Include the runtime version in the container image name. This question asks about the most reliable and reproducible way to lock a specific runtime version in a containerized application. Think about where the container image is defined. Correct answer, C. Specify the runtime version in the Dockerfile. The Dockerfile is the blueprint for your container image. Specifying the runtime version directly in the Dockerfile, for example, from node 18.12.-alpine3.16, ensures that the correct version is baked into the image at build time. This guarantees reproducibility across all environments where the image is deployed. Why the other options are wrong. Option A, environment variables can influence runtime behavior at startup, but do not guarantee that the correct runtime version is installed in the container image itself. The runtime must already be present in the image. Option B, the deployment YAML file defines how Kubernetes or other orchestrators should run the container, but it references a pre-built image. The runtime version must be set at image build time, not deployment time. Option D, including the version in the container image name is not a standard practice. Image naming conventions use tags, e.g., myapp 1.0 for versioning the app, not for specifying language runtime versions. Exam tip Dockerfile from instruction equals runtime version locked at build time, consistent across all environments. If this video is helping you, support us by hitting the like button, and don't forget to subscribe for more content like this. Question 11. You are using Azure Blob storage to store large media files. Which features can you leverage to optimize the delivery of these files to users globally, improving performance and reducing latency? Options. A. Implement read access geo-redundant storage, RAGRS. B. Enable geo-redundant storage, GRS. C. Use Azure Content Delivery Network, CDN. D. Configure Content Delivery Network, CDN for Azure Storage. E. Use Azure Traffic Manager. F. Use Azure Blob Storage Lifecycle Management. This question asks which features optimize global content delivery and reduce latency for media files. Focus on caching and edge distribution rather than redundancy. Correct answer, C and D. Azure CDN, C, distributes content across multiple edge locations worldwide, caching files closer to users and dramatically reducing latency. Configuring CDN for Azure Storage, D, creates a seamless integration where your blob storage content is served through CDN edge nodes, providing optimized delivery globally. Why the other options are wrong. Option A, RAGRS provides read access from a secondary region for disaster recovery and redundancy. While it improves availability, it does not cache content at edge locations globally or reduce end-user latency like a CDN. Option B, GRS replicates data to a paired secondary region for disaster recovery. It does not optimize content delivery performance for end users globally. Option E, Azure Traffic Manager routes DNS queries to the best endpoint based on routing rules. It does not cache content at edge locations and is not designed for optimizing media file delivery. Option F, Blob Lifecycle Management automates tiering and deletion of data based on age or last access. It manages storage costs and data retention, but does not improve delivery performance. Exam tip, Azure CDN equals edge caching's global delivery, fastest path to users worldwide. Question 12. You are implementing Azure Backup to protect virtual machines and other Azure resources. How can you configure Azure Backup to create regular backups, define retention policies, and restore resources in the event of data loss or accidental deletion? Options. A. Use Azure Site Recovery to back up and replicate virtual machines. B. Use Azure Storage Redundancy Options, LRS, ZRS, GRS, to ensure data redundancy and availability. C. Create backup policies that define backup schedules, retention periods, and instant restore options, and assign them to relevant resources. D. Manually trigger backups for each resource whenever needed and store them indefinitely. This question asks how Azure Backup is properly configured for automation, retention, and recovery. Focus on the policy-based approach built into Azure Backup. Correct answer, C. Create backup policies that define backup schedules, retention periods, and instant restore options, and assign them to relevant resources. Azure Backup policies allow you to define backup schedules, daily, weekly, retention periods for different recovery point types, and instant restore options for quick recovery. Assigning these policies to resources automates the entire backup lifecycle without manual intervention. Why the other options are wrong. Option A. Azure Site Recovery is a disaster recovery service designed for VM replication and failover to a secondary region. It is not the same as Azure Backup and does not manage backup policies or retention. Option B. Storage Redundancy Options, LRS, ZRS, GRS, replicate data within or across regions for durability. They do not provide scheduled backups, point-in-time recovery, or restore capabilities. Option D. Manually triggering backups is error-prone, inconsistent, and does not enforce retention policies. This approach does not meet the requirement for automated, policy-driven backup management. Exam tip: Azure Backup equals policy, schedule plus retention plus instant restore assigned to resources. Question 13. You have configured Azure Site Recovery for your Azure VMs. You want to test the failover process without impacting the production environment. Which Azure Site Recovery feature can you use to perform a test failover? Options. A. Unplanned failover. B. Test failover. C. Planned failover. This question asks about the site recovery option that validates your DR plan without any production impact. Remember, testing should never touch live workloads. Correct answer B. Test failover. Test failover is the only Azure Site Recovery option that simulates a failover in a safe, isolated environment without impacting your production workloads. It spins up a replica environment so you can validate recovery time objectives, RTO, and recovery point objectives, RPO. Why the other options are wrong. Option A. Unplanned failover is triggered when there is an actual disaster or unexpected outage. It immediately switches production workloads to the secondary region and directly impacts the production environment. Option C. Planned failover is a scheduled, graceful migration to the secondary region, typically for maintenance or region evacuation. While controlled, it still moves production workloads and is not a test scenario. Exam tip: test failover equals isolated DR drill, no production impact. Question 14. You are configuring Azure Bastion to provide secure access to virtual machines in a private subnet. How would you set up Azure Bastion and connect to VMs without exposing them to the public internet? Options. A. Deploy Azure Bastion in a public subnet and allow inbound RDP SSH traffic from any source. B. Deploy Azure Bastion in the same private subnet as the VMs and configure a public IP address for it. C. Deploy Azure Bastion in a dedicated subnet, Azure Bastion subnet, with a public IP address. Configure NSG rules to allow access to the Bastion host and restrict RDP SSH traffic to the private subnet. D. Connect to VMs directly using their private IP addresses from the internet. This question tests your understanding of Azure Bastion's required architecture. Know that Bastion requires a specifically named subnet and serves as the secure bridge between browsers and VMs. Correct answer. C. Deploy Azure Bastion in a dedicated subnet, Azure Bastion subnet, with a public IP address. Configure NSG rules. Azure Bastion must be deployed in a subnet named exactly Azure Bastion subnet with a public IP address. This allows users to connect via browser-based RDP SSH through the Azure portal. NSG rules then restrict direct RDP SSH to VMs. Only traffic from the Bastion subnet is allowed to reach the VMs, eliminating the need to expose VMs to the public internet. Why the other options are wrong. Option A. Deploying Bastion in a general public subnet and allowing inbound RDP SSH from any source defeats the security purpose of Bastion. This exposes VMs directly to the internet. Option B, Azure Bastion cannot be deployed in the same subnet as the VMs. It requires its own dedicated subnet named Azure Bastion Subnet, which is a hard architectural requirement. Option D, connecting to VMs directly via private IPs from the internet is not possible without a VPN or ExpressRoute connection. Bastion provides browser-based access without requiring these. Exam tip Azure Bastion equals Azure Bastion Subnet plus public IP plus browser. RDP SSH, VMs stay private. Question 15. You are tasked with designing a disaster recovery strategy for your Azure environment. How would you implement Azure Site Recovery to replicate virtual machines and ensure business continuity in the event of a regional outage? Options. A. Use Azure Site Recovery to configure load balancing for virtual machines in the same region. B. Use Azure Site Recovery to migrate virtual machines between subscriptions without replication. C. Set up Azure Site Recovery to replicate virtual machines to a secondary region, create recovery plans, and test failover processes regularly. D. Use Azure Site Recovery to back up virtual machines to Azure Blob storage. This question tests your understanding of Azure Site Recovery's primary purpose, cross-region VM replication for disaster recovery. Distinguish it from backup, load balancing, and migration. Correct answer, C. Set up Azure Site Recovery to replicate virtual machines to a secondary region, create recovery plans, and test failover processes regularly. Azure Site Recovery continuously replicates VMs to a paired secondary region, maintains recovery plans, ordered failover sequences, and supports regular test failovers to validate the DR strategy. This ensures minimal downtime and data loss in the event of a regional outage. Why the other options are wrong. Option A. Load balancing within the same region is handled by Azure Load Balancer or Application Gateway, not Azure Site Recovery. Site Recovery is designed for cross-region disaster recovery. Option B. VM migration between subscriptions uses Azure Migrate or manual methods. Site Recovery is not designed for subscription-to-subscription migration without replication. Option D. Azure Backup is the service used to back up VMs to recovery services vaults, backed by Azure Storage. Site Recovery is for replication and failover, not point-in-time backup. Question 16. You want to grant a user read-only access to Azure resources in a specific resource group. Which built-in RBAC role would you assign to the user? Options. A. User Access Administrator. B. Contributor. C. Reader. D. Owner. This question tests RBAC fundamentals. Match the role name to its permission scope. Read-only is a very specific access level. Correct answer C. Reader, the reader role in Azure RBAC, provides read-only access to all resources within the assigned scope, in this case, the resource group. Users can view resources but cannot make any changes or manage access. Why the other options are wrong. Option A, User Access Administrator can manage user access to Azure resources, role assignments, but does not provide general read access to resource configurations. Option B, Contributor allows creating and managing resources but cannot assign roles. This is more than read-only. It violates the principle of least privilege here. Option D, Owner has full access, including the ability to assign roles to others. This is the highest privilege level and far exceeds the read-only requirement. Exam tip Reader equals view only. Contributor equals manage resources. Owner equals full control plus role assignment. Question 17. Your company's security policy mandates the use of Web Application Firewall, WAF, to protect web applications from common vulnerabilities and attacks. How can you integrate Azure WAF with your app service to enhance its security posture? Options. A. Azure Application Gateway with WAF. B. Azure Front Door with WAF. C. Third-party WAF solution integrated with app service. D. Directly through app service's WAF integration. This question asks about the recommended Azure native WAF integration for app service. Focus on the service that provides deep integration for regional web application protection. Correct answer, A. Azure Application Gateway with WAF. Azure Application Gateway with WAF provides the most comprehensive and recommended integration for app service. It offers OWASP rule sets, custom rules, bot protection, and operates at layer 7, HTTP/HTTPS. It acts as a reverse proxy between clients and the app service, inspecting all traffic before it reaches the application. Why the other options are wrong. Option B, Azure Front Door with WAF is an excellent global load balancing and WAF solution, but it is primarily suited for global multi-region applications. For app service protection in a single region, Application Gateway is the more direct and recommended approach. Option C, third-party WAF solutions can work, but they are not the recommended Azure native approach. Using Azure native services simplifies management and integration. Option D, app service does not have a built-in WAF integration feature. WAF must be implemented at the gateway or CDN layer in front of app service. Exam tip: app service plus WAF equals Azure Application Gateway, layer 7 protection with OWASP rules. Question 18. You are implementing Azure Policy to control resource deployment and configurations. How can you create custom policy definitions using Azure Policy language to enforce specific rules and standards in your Azure environment? Options. A. Use PowerShell subnets to create custom policy definitions with complex logic. B. Use Azure deployment stacks to create and apply custom policy definitions across multiple subscriptions. C. Use JSON to define custom policy rules and conditions, specifying allowed or denied resource configurations. D. Use Azure Resource Manager templates to define custom policy definitions. This question focuses on how Azure policy definitions are authored. Know the native language and format used to write policy rules. Correct answer C. Use JSON to define custom policy rules and conditions, specifying allowed or denied resource configurations. Azure policy definitions are written in JSON format. The JSON structure defines the policy rule, affect, deny, audit, append, deploy if not exists, etc., and conditions using Azure policy language expressions. Custom policies allow organizations to enforce specific standards beyond the built-in policies. Why the other options are wrong. Option A, PowerShell commandlets can be used to deploy or assign existing policy definitions, but policies themselves are not written in PowerShell. The policy definition language is JSON. Option B, Azure deployment stacks are used to package and apply governance artifacts, including policies, but they are not used to create the custom policy definitions themselves. Option D, ARM templates define Azure resources for deployment. While policies can be deployed via ARM templates, the policy definition itself is always written in JSON using Azure policy language, not ARM template syntax. Exam tip: Azure policies written in JSON define rules, conditions, and effects. Question 19. You are troubleshooting network connectivity issues with an Azure VM. Which Azure tools or features can you use to diagnose network problems, trace routes, and verify network settings for the VM? Options. A. Network Watcher. B. Traffic Manager. C. Application Gateway. D. VPN Gateway. This question asks which Azure service provides network diagnostics, topology visualization, and packet capture capabilities for VMs. Correct answer: A. Network Watcher. Azure Network Watcher provides a comprehensive suite of network diagnostic tools, including Connection Monitor, IP Flow Verify, Next Hop Analysis, Packet Capture, and VPN Troubleshooting. It is the primary tool for diagnosing and resolving network issues with Azure VMs. Why the other options are wrong. Option B, Traffic Manager is a DNS-based load balancer for routing traffic across global endpoints. It does not provide network diagnostics or troubleshooting capabilities for individual VMs. Option C, Application Gateway is a Layer 7 load balancer and WAF. It manages inbound HTTP/HTTPS traffic, but does not provide VM-level network diagnostics. Option D, VPN Gateway creates encrypted tunnels between Azure and on-premises networks. While it has some diagnostic tools, it is not the general-purpose network troubleshooting service for Azure VMs. Exam tip: Network Watcher equals IP Flow Verify plus Packet Capture, Next Hop, Connection Monitor, VM Network Diagnostics. Question 20. Your company's compliance requirements mandate that you retain logs and metrics for a specific period. How can you configure retention policies in Azure Monitor to ensure that log data is stored for the required duration? Options. A. Modify the Log Analytics workspace settings. B. Use Azure Storage Lifecycle Management policies. C. Enable diagnostic settings on each Azure resource. D. Create an Azure policy to enforce retention rules. This question focuses on where retention periods for Azure Monitor log data are configured. Know the difference between configuring retention versus collecting logs. Correct answer: A. Modify the Log Analytics workspace settings. The Log Analytics workspace settings provide the most direct way to configure the retention period for Azure Monitor logs. You can set the retention period from 30 days up to 730 days. 2 years, directly in the workspace properties. This controls how long collected log data is retained before automatic deletion. Why the other options are wrong. Option B. Azure Storage Lifecycle Management manages blob data tiers and deletion in storage accounts. Log Analytics workspace data is not stored directly in a blob storage account that you manage, so lifecycle policies don't apply here. Option C, enabling diagnostic settings on Azure Resources controls which logs and metrics are collected and sent to Log Analytics. It determines what data is ingested, not how long it is retained after ingestion. Option D, Azure Policy can enforce governance rules across resources, but is not the mechanism for setting log retention duration within a Log Analytics workspace. Exam tip: log retention equals Log Analytics workspace settings. Set duration from 30 to 730 days. Question 21. You are deploying an Azure virtual network using an ARM template. You need to define a subnet within the virtual network and specify its address prefix. Which property or attribute within the virtual network resource definition would you use to configure the subnet? Options: A. Address prefixes. B. Address space. C. Network security group. D. Subnets. This question tests your knowledge of the ARM template structure for virtual networks. Know the difference between the VNet address space and the subnet definitions. Correct answer: D. Subnets. The subnets property within the virtual network resource definition is used to define one or more subnets and their address prefixes. Each subnet entry specifies a name and an address prefix property that defines the IP range for that subnet. Why the other options are wrong. Option A. Address prefixes is a property inside the address space object that defines the overall IP address range for the entire virtual network, not for individual subnets. Option B. Address space is the parent property on the VNet resource that contains the address prefixes array. It defines the VNet's address range, not subnet configurations. Option C. Network security group is used to associate an NSG with a subnet or network interface. It does not define the subnet itself or its address prefix. Exam tip: VNet ARM template. Address space, VNet range. Subnets. Individual subnet definitions. Question 22. You are managing multiple ARM template deployments across different environments. You want to track the deployment history and view detailed information about each deployment, including the resources deployed and any errors that occurred. Which Azure feature or service can you use to access this deployment history and troubleshoot issues? Options: A. Azure Monitor. B. Azure Activity Log. C. Azure Service Health. D. Azure Resource Manager ARM Deployment History. This question asks about tracking ARM template deployment history specifically. Know which feature provides detailed deployment records, including success, failure, and resource lists. Correct answer: D. Azure Resource Manager ARM. Deployment history. ARM deployment history, accessible through the Azure portal under each resource group's deployment section, provides a complete record of all template deployments. You can view deployment status, the template used, parameters, resources deployed, and any error messages for troubleshooting. Why the other options are wrong. Option A. Azure Monitor collects telemetry, metrics, and logs for resource health and performance. While it includes activity logs, it does not provide ARM template-specific deployment details like parameter values and resource lists. Option B. Azure Activity Log records control plane events, including deployment triggers, but it does not show the detailed deployment information, such as the template contents, all deployed resources, and nested deployment errors. Option C. Azure Service Health provides information about Azure platform issues, maintenance, and health advisories. It does not track resource deployments or ARM template history. Exam tip: ARM deployment history equals resource group, deployments, full plus resources, errors. Question 23. You are backing up an Azure VM that has a high churn rate with frequent changes to its data. Which Azure Backup feature can you use to optimize backup performance and reduce storage costs for this scenario? Options: A. Geo-redundant backup. B. Incremental backup. C. Offline seeding. D. Cross-region restore. This question focuses on optimizing backup for high-change environments. Think about which backup type minimizes data transferred and storage used. Correct answer: B. Incremental backup. Incremental backups are ideal for VMs with high churn rates because they only back up the blocks that have changed since the last backup, not the entire disk. This significantly reduces storage requirements, backup transfer time, and overall costs. Why the other options are wrong? Option A, geo-redundant backup replicates backup data to a paired region for disaster recovery. It is a redundancy option, not a performance optimization for high churn scenarios. Option C, offline seeding is used for initial bulk data transfer to Azure from on-premises using physical devices. It is not relevant to ongoing backup optimization for a running Azure VM. Option D, cross-region restore allows restoring backup data to a secondary region. It is a restore capability, not a backup performance or cost optimization feature. Exam tip, high churn VM equals incremental backup, only changed blocks equals less storage plus faster backups. Question 24. Your organization wants to monitor the availability and performance of its web applications from different geographic locations. Which Azure service can you use to simulate user traffic from various regions and generate reports on application performance and availability? Options: A, Azure Monitor, B, Azure Traffic Manager, C, Azure Application Insights, D, Azure Application Insights Availability Tests. This question asks about simulating real user traffic from global locations to test availability and response times. Know the specific feature within Application Insights for this purpose. Correct answer D, Azure Application Insights Availability Tests. Azure Application Insights Availability Tests, formerly called web tests, allow you to send synthetic HTTP requests to your web application from multiple locations worldwide at regular intervals. They measure response time, check status codes, and generate availability reports and alerts, making them ideal for proactive monitoring from a global perspective. Why the other options are wrong? Option A, Azure Monitor is the platform for collecting and analyzing telemetry from Azure resources. While Application Insights is a component of Azure Monitor, selecting just Azure Monitor is too broad. The specific feature needed is availability tests within Application Insights. Option B, Azure Traffic Manager routes DNS queries to the best endpoint based on routing policies. It improves traffic distribution but does not simulate user traffic or generate availability performance reports. Option C, Azure Application Insights provides broad application performance monitoring, including request rates, dependencies, and exceptions. However, the specific capability for simulating traffic from geographic locations is the Availability Tests feature within Application Insights. Exam tip, Global Synthetic Monitoring equals Application Insights Availability Tests, multi-region pings plus reports. Question 25. You are tasked with providing temporary, time-limited access to an Azure Blob storage container for a third-party vendor. How would you achieve this securely while ensuring that access is automatically revoked after the specified time period? Options A, grant the vendor contributor access to the storage account. B, generate a shared access signature, SAS, with an expiry time. C, share the storage account keys with the vendor. D, create a new storage account specifically for the vendor. This question asks about granting temporary scoped access without permanent credentials. Think about which Azure storage feature is designed specifically for time-limited delegated access. Correct answer B, generate a shared access signature, SAS, with an expiry time. Shared access signatures, SAS, provide a secure, time-limited URL that grants access to specific storage resources, blobs, containers, queues, tables, with defined permissions. Setting an expiry time ensures access is automatically revoked after the specified period without requiring any manual action. Why the other options are wrong? Option A, granting contributor access assigns a permanent RBAC role to the vendor's identity. This is not time-limited and gives broad permissions across the storage account, violating the principle of least privilege. Option C, sharing storage account keys gives full control over the entire storage account. Keys do not expire automatically and can be difficult to revoke. This is a serious security risk for third-party access. Option D, creating a new storage account for the vendor adds unnecessary infrastructure and cost. It still does not address the requirement for automatic access revocation after a time period. Exam tip, SAS equals time-limited plus scoped permissions auto-expiry, safest for third-party access. You just powered through 25 critical AZ-104 exam questions. You mapped out storage architectures, untangled app service diagnostics, and lockdown Azure Monitor deployments. These questions provide a direct preview of the exact domains you'll face on test day. But that initial victory is often masking a much larger challenge looming on the horizon. Candidates who stop practicing right now are walking straight into a statistical trap. Relying on this baseline alone usually results in a failing schooler, stalling most candidates in the 65 to 72% range. Bridging the gap to that safe 80 to 90% threshold requires a significant jump in technical density. It means tackling Tier 1 difficulty scenarios and dissecting high-level Azure engineer problems. Exposure is the only way to survive the engineered distractors and exam traps waiting to derail an incomplete domain breakdown. Navigating that minefield requires an exclusive map of the entire environment. We built that map as a complete arsenal for members to bypass the traps and guarantee a pass. Inside, you get detailed explanations, Tier 1 scenarios, and over 50 downloadable practice PDFs for offline study. These mock tests are updated monthly, ensuring you are always aligned with the current exam blueprints. Unlock questions 26 through 57 and join the 95% pass rate community. Join today. Start question 26 tonight. Access the full 57-question mock test to pass your A104 exam this month.